In this video, I'm going to talk a little bit about how you interpret interaction effects in the context of what your coding scheme is. So we've got up top here a linear regression that I trained on some of our Titanic data. We've got our intercept, we've got weights on sex, a weight on age, and a weight on their interaction. For our coding, we have for sex, female is 1, male is 0. For age, child is 1, adult is 0. So, what do all of these numbers mean? 0.18 is the prediction for a male adult. We get that because sex is 0, age is 0, and that means everything to the right is just going away. We just have that very first number. What is 0.6? 0.6 is how much better off a female adult is than a male adult. So we still ignore everything that has an age on it. And that just means that the difference here is 0 and 1 for sex. So 0.6 is our difference there. So as sex changes between 0 and 1, we're multiplying either 0 or 1 times 0.6. So that's how we will get the number that a female is 0.6 better off. Similarly, 0.15 is your age difference. So adult or child. It's how much better a male child is than a male adult because we've gone and set sex back to 0. This last number right here, this minus 0.26, that is how much worse off a female child would be than if you just added the boost for sex and age together. So if you just added, or if you did not have that interaction effect, you just included sex and age but kept the rest of the model intact, you would predict that a female child would be 0.18 plus 0.60 plus 0.15. So that's 0.93. That is an unrealistically high prediction. So in the event that you have a female child, so 1 for both of them, you subtract 0.26 from it. So you, instead of get 0.93, it's 0.67? That's not right. I guess it is. In any event, that gives you what the prediction is for a female child. And you have to have that little adjustment in there because part of what happens in our training data is sex and age are slightly overlapping, or they're slightly correlated within the sample of data I had. So pulling that out on the side lets us look at the two more independently of one another. And that's why we are also getting a positive effect for sex and a positive effect for age. So yes, being a child helps you, and yes, being a female helps you. So we're getting coefficients that are useful to us, that are what we would want them to be and what we'd expect them to be in terms of interpretation. But there is that little normalizing effect at the end, because while sex and age are both good, part of their improvement is simply because they're both predicting very similar things. Or they're predicting the same people. Now I want to show what interaction effects would be if you had contrast coding. So in this one, we've got 0.49 as our intercept, plus 0.47 times sex, plus 0.01 times age, minus 0.07 times sex times age. So because this is contrast coded, we can have zeros that mean we're just going to ignore it. We're going to look at what it's like for people that we're not considering the groups, for everyone regardless of that group. So 0.49 is what it would be if you had sex and age equal to 0. That doesn't represent any actual option available to you, but it gives you a base level for the group. A typical passenger, not looking at any other information, not knowing anything else about them, is a 0.49 survival. What's the 0.47 that comes next? It's how much better off a female is than a male. So how much more likely a female is to survive than a male, ignoring their age. Similarly, we have 0.01 is how much better off a child is than an adult, ignoring their sex. Now, the last little bit is somewhat complicated, but what it measures is how much more a male would be helped by being a child than a female would be. So again, we're looking at, there is some overlap between why the algorithm predicts sex and child surviving, because there are more female children than there are male children in the subsample I had. So part of what it's predicting is an overlap. As a result, males gain more benefit from being a child than a female would. And because of some odd math, it's actually can be flipped around to say how much better off, how much worse off a male is for being an adult than a female is, or a number of other equivalent things. So what it's looking at there is your penalty, or how much more it helps you if you're in the bad for one group to switch to the good for the other.